So if I am solving for 2 sine theta plus 1 equals 0, I want to get sine of theta by itself. And I'm going to do that the same way I would do any algebra equation solving. I'm going to subtract that 1 over. That leaves me with 2 sine of theta equals -1. Then I am going to divide both sides by 2. And I'm going to get that the sine of theta equals -1/2. Now, I know the sine of theta. The sine of theta equals -1/2. My goal is to figure out what angle gives me that answer. So if I'm only talking about 1 unit circle, and I'm not talking about that I could keep going past 360, then I am going to find theta that gives me a sine or a y value of -1/2. First of all, I know that's going to be in which 2 quadrants for sine. Sine is my y value. Which 2 quadrants are negative for my y value? The third and fourth. So then I just have to worry about 30-degree angles in the third and fourth, because that is a sine value of 1/2. All right? These will typically be answered in radians. So remember, your 30-degree angles are your ones that have a denominator of 6. Pi over 6, right? 5 pi over 6, 7 pi over 6, 11 pi over 6. Those are the ones that give you 30-degree angles. So in this case, I am going to say, well, right here has a sine of -1/2. That is 7 pi over 6. That's my angle. So that must mean that theta could be 7 pi over 6. That would give me a sine of -1/2. If I look at my fourth quadrant, 11 pi over 6 also has a sine of -1/2. So another answer that I could have here is 11 pi over 6. All I'm trying to do is get the trig value by itself and then figure out what angle gives me that trig value. All right? So we have what's called primary solutions, and that's what we've been solving for. And then we have what's called general solutions. I'm going to show you what a general solution looks like, but for the most part, I'm always going to want a primary. A primary solution assumes that you're only going to do one circle. So you're only going to look at from 0 to 2 pi, one complete circle, or for your advantage that way. If you think about it, though, you could keep going. So like I could have an angle that's one full circle, 360 degrees. I could keep going, 720, right? That's another circle. So I could just keep going and going, and it would just keep repeating. And that's called a general solution. So if you see in your answers something that's being multiplied by it, it's just indicating, hey, you could keep looping, and you would end up on the same angle every single circle. And they would always have the same sign, or they would always have the same cosine. Every time you ended up in a circle, you'd be right back where you started, and those would be coterminal angles with the same trig functions, right? But for me, on my test, I'm only going to ask you to give me what happens in one full circle from 0 to 2 pi, all right? But that's what it's asking for when it says general solutions. Let's look at this particular one. All right. If I'm solving something like this and I have trig functions in multiple places, I'm going to try to group those. So I want to group all of my tangent squareds. I'm going to do that just by adding this guy over. So I'm going to say add that tangent squared over, and it will cancel. We have that 6. If I have a tangent squared plus a tangent squared, I am going to get a 2 tangent squared. And then I still need to get rid of the 2, so I'm going to divide both sides. So tangent squared of x equals 3. All right? How do I get rid of a square when I'm solving an equation? Take the square root. So I'm going to square root both sides. So the tangent of x, remember when you're doing a square root with a variable, could be positive or negative square root of 3. All right? With tangents, all right? Tangents is a little more difficult because it doesn't actually give you that on your unit circle. Square root of 3 by itself means that square root of 3 ends up on top. which means the sine value of whatever angle we're looking for is going to look like that, sine over cosine. Because if I were to change flip that, I would get just the square root of 3, okay? Had it been square root of 3 over 3, that would have indicated that my square root of 3 was on bottom, which would be the exact opposite of this, okay? It would be 1/2 over square root of 3 over 2. All right, so if you start to learn that rhythm of the tangents, square root of 3 is going to be where your sine value is that. Square root of 3 over 3 would be where your sine value is 1/2, okay? So a tangent that gives you a square root of 3 is going to be your 60-degree angles, yes, or your pi over 6s. I mean pi over 3s, right? So that happens 4 times. The reason it happens 4 times is because we are considering the positive and the negative. So every 60-degree angle, every pi over 3 is going to be my answer. I'm going to have an answer of pi over 3. That's positive. 2 pi over 3, negative. 4 pi over 3, that's another positive. And 5 pi over 3, that's another negative. So this one will actually have 4 answers. My answers to this will be all 4 of those. All right. So pi over 3 is my 60-degree. That's going to give me a tangent of square root of 3. Pi over 3 are 6s are my 30s. Those are going to give me a square root of 3 over 3. So you just have to, if you don't know, you can set them both up and just see which one gives you the right tangent. Remember, tangent is your y over your x, your sine over your cosine. So when you get to something where you have multiple trig functions in here, you want to rewrite them, all right? You don't want to have multiple trig functions going on for the most part unless you can factor something out. In this case, I can't factor anything out. So because I have a squared in here, I can actually rewrite this using one of my Pythagorean identities. Remember, sine squared plus cosine squared is 1. So if I want to replace sine squared with something, I could just say, well, sine squared is 1 minus cosine squared. Right? And then I have plus cosine plus 1. I can combine my like terms, which is that 1. All right. Here's what I do. Think of this as factoring. I'm going to pull a negative out of everything just to make it a little bit easier. All right? Because I don't like having that first one as a negative. If I were factoring this as just an equation, so if I had x squared minus x minus 2, how would I factor it? How would I factor? Factors of 2 that give me 1. A negative 2 and a positive 1, right? Everybody see that? So when you start factoring these with trig functions, just think of what you would do if it was just a variable. All right, I would say, well, this is cosine of x minus 2. Cosine of x plus 1, right? And then I can just set each one equal to 0. Cosine of x minus 2 equals 0. Cosine of x plus 1 equals 0. If I add that, this is called the unit circle. What's the very largest cosine I can have? The largest cosine I can have is 1. The furthest it goes on that circle is 1. My radius is 1, right? I can't get any bigger than 1, so this will never give me an answer. But there is an angle that gives me a cosine of negative 1. What angle on your unit circle gives you a x value, a cosine value of negative 1?
Angle 180?
Yep, so just pi. Yep. So for something like this b, I'm actually just going to move everything to one side. All right, so I'm just going to go ahead and move everything over. I have 2 tangent of x sine of x minus square root of 2 tangent of x. And I have that equal to 0. When I have something like this, the only way to factor it is just to take out a tangent of x, right? The first group has a tangent of x, the second group has a tangent of x. So I am going to factor out a tangent of x. That will leave me 2 sine of x minus just the square root of 2. And now it's factored. I can just set each factor equal to 0. No problem. So I can say, well, the tangent of x will equal 0. That is where my sine value is 0. It's the numerator. So where on the unit circle do I have a sine value or a y value of 0?
360, right?
At 0 and at pi, right? For that next piece, 2 sine of x minus the square root of 2 equals 0. Add square root of 2, divide by 2. Sine of x equals the square root of 2 over 2. That's easy. We know that's what type of angle. What type of angle is square root of 2 over 2? It's a 45, pi over 4. Sine value is positive. Which quadrants give me a sine value that's positive?
The first one.
The first one and the?
Fourth one.
That's x value. Sine value. Y value, first and the second, right? So we have pi over 4 and 3 pi over 4, right? Square root of 2 over 2 is always your 45-degree angles. Sine value is y. Y is positive in the top. First two, 1, 2.
Why do you not do negative?
I'm not taking a square root here. So I don't have to worry about the positive and negative. It's just solving. If it were sine squared, and that's how I got square root of 2 over 2, then I would have to do positive and negative for both of them. So cosecant and sine are similar, but not the same. All right. So when they're close, you can rewrite it and it's going to work out. So if I were to rewrite cosecant, what am I going to write that as? 1 over sine. So I can actually write this as 3 over sine. Right? Think about this like when we were simplifying. That is sine over 1. So I need a common denominator. What is my common denominator? It's just sine. So I can multiply the top and bottom by sine. So I get 3 minus sine squared of x over the sine of x. I really want to get that denominator out, so I'm just going to multiply both sides by that sine of x. So I have 3 minus the sine squared of x equals 2 sine of x. All right? When I have a square and I have no way to get rid of it, I'm going to just move everything to one side and do my factoring. So I'm going to move my sine squared over and my 3 over. So I have a positive sine squared of x, a positive 2 sine of x, and then a negative 3 because I've subtracted that 3 over. And again, when you have something like this, if you need to over to the side, write it as variables, write it that way. Sine squared, well, just write it as x squared. 2 sine, just write as 2x minus 3. That will make your brain understand this factoring easier. All right? So if I need to factor this one, I would say, well, factors of 3 that add up to give me 2, that's going to be a positive 3 and a negative 1. Right? That's how I would do that factoring normally. So then do the same thing, but instead of writing an x, write sine of x. So I'm going to say, well, it's sine of x plus 3 and sine of x minus 1, right? And then I can just set them equal to 0 and solve. Again, sine of x subtract the 3 is negative 3. Remember, my sine only goes from 1 to negative 1. So I'm never going to have a sine value of something like negative 3. So this is not going to give me an answer. But sine of x, if I move that 1 over, equals 1. There is one place on the unit circle that has a sine value of 1. What is it? Pi over 2. And that's my answer. Again, this is asking for general and primary. I'm only going to ask you for the primary. All right, so you don't have to do it where it loops. So the primary solutions would be wherever it occurs in one full circle. All right, so for this one, you'll notice that you have this 3x in there. We're kind of going to ignore that until the very end. We're going to do everything else exactly the same. So we have 2 cosine of 3x equals the square root of 3. We're going to go ahead and just solve for that cosine as if that 3x was not there. So the cosine of 3x equals the square root of 3 over 2. So we are looking for places where it has a cosine of square root of 3 over 2. It happens twice on the unit circle. All right, what are the 2 places that it happens on the unit circle? Cosine of square root of 3 over 2.
The cosine?
Should be the first and fourth, right, is positive. And it should be your 6 over 6's, right? Your 30-degree angles have a cosine of square root of 3 over 2. So that's pi over 6. Does everybody see pi over 6 on your unit circle? Should have a cosine of square root of 3 over 2, an x value of square root of 3 over 2. And then the next one's in their fourth quadrant. What is your pi over 6 in your fourth quadrant?
It's a 330 degrees. That doesn't have listed.
11 pi over 6, right? Yes, 11 pi over 6 should have a cosine or an x value of square root of 3 over 2. Okay? Now, normally we're solving for x, right? When we do that, when we figure out what angle gave me that cosine. But remember here, that's a 3x. So 3x equals pi over 6, and 3x equals 11 pi over 6. So I'm not quite done when I get to this point. What do I need to do to give the x value? Just divide by 3. Dividing by 3 is the same thing as multiplying by what? 1/3. So the reason I ask that is because I have fractions over here. That makes my life a little bit easier to think of it as multiplication by 1/3. Because my 2 answers here are going to be pi over 18 and 11 pi over 18. The general solution, if you'll notice in your book, they're multiplying it by n, if n is 1, if n is 2, if n is 3. That's just saying if I were to do a full circle. So if I were to go a full circle around and hit this angle again, or a full circle around and hit it again, right? But I'm just going to ask you for where it happens in the unit circle itself. And I'm not going to make you go through and then find all the over 18s within the 360. I'm just going to ask for these 2. I'm not going to ask for all the other times that it could happen before you get to 2 pi, which is what would normally happen if you had pi over 18.